Hello, welcome to Chapter 8, Section 3, Adding and Subtracting Rational Expressions. In the last section, we multiplied and divided rational expressions. And of course, you can tell from this one, we're going to be adding and subtracting. So, just like last week or last section, we were comparing rational expressions or how you multiply them with comparing it with like how you multiply fractions. This is the same idea. We're going to add like we would add fractions, and the big thing about that is we have to find a common denominator. There are a lot of different common denominators, an infinite number actually. So usually that's why we say we want to find the least common denominator. We want to find the smallest one. That's probably not going to be an issue with the rational expressions, but I just want to make sure that we say that. I'm going to focus in on finding a common denominator, where I know you're thinking least common denominator, but it's the same idea. Okay? For this video, for this example, we're going to start off kind of easy. We're going to give you rational expressions that already have a common denominator. So if I look at this first example, I'll move it up so you can see it. As you guys know, my 8.5 by 11 paper that I use doesn't match up well with the window that I'm using for my iPad. But anyway, so I've got this rational expression, 3x subtract 4 over x plus 3. And this one, which is 2x plus 5 over x plus 3. So when I add, and this is something I tend to do as a math person, as a math teacher, and just as a mathematician in general. I try to avoid using the equal sign when I mean the next step. It's just bad form. So I like to draw arrows. This is going to take me to this step, that's going to take me to this step. They're all going to be equivalent, that's true, but the equal sign doesn't always mean what people think that it means, so I try to avoid it. So I know you probably want me to write an equals right here, but I'm not going to. I'm going to write an arrow, which means I'm going to take it to the next part. Okay, so I already have a common denominator. X plus 3, x plus 3. Those two are the same. So that makes a lot of this work easier, at least in this first video. In the next video, we're going to talk about how to make them the same. Actually, it won't be the next video, it'll be the video after that, but don't worry about that. So that's our house phone. Please ignore that. When I add this, my new denominator is still going to be x plus 3. And in the numerator, I'm adding everything together. So I get 3x subtract 4 plus 2x plus 5. And the only thing I have left to do is just simplify what's in the top. So I still get x plus 3 in the denominator. And in the top, I got 3x plus 2x, which is 5x, and negative 4 plus 5, which is 1. Now it doesn't look like I have anything that's going to factor, so I can reduce or simplify, so I'm going to leave it like that. Part of the question says, identify any x values which make this undefined. Well, that means what values can you replace x with that is going to make the denominator, just the denominator, equal 0. So if I think about something plus 3 equals 0, then that tells me that x cannot equal negative 3. Don't let x equal negative 3, because negative 3 plus 3 equals 0. And I probably should have pointed at this, but it's the same thing. Negative 3 does not work here. Negative 3 does not work here. For the second problem, and I'm only doing 2 in this example, so this will be a relatively short example. My denominator is x squared plus 2. So I'm going to have x to the second power plus 2. And in my numerator, I get 2x subtract 1, subtract 4x plus 4. Now, subtraction means to add the opposite. So I can think of this as subtracting positive 4x means to add negative 4x, and subtracting positive 4 means to add negative 4. Of course, that would be the same as if I did 2x subtract 1, subtract 4x, subtract 4. But I usually find that it's easier if I explain it in terms of adding negative whatever. Of course, I didn't do that with that one, but that's okay. So now I'm going to combine my, simplify in the top, combine my terms. 2x plus negative 4x is negative 2x. And negative 1 plus negative 4 is negative 5, which is the same as subtracting 5. And of course, my denominator is still x squared plus 2. All right, so let's do the last part where we figure out any x values that's going to make the denominator undefined. Well, this tells me that to make the bottom undefined, then I'm going to have x squared plus 2 has to equal 0 to make it undefined. So then, and I know we got into this last time, that then I'm going to turn around and say, well, don't let that happen. So I'm going to find out what makes it work, and then I'm going to say, don't let that happen. So if I say x to the second power plus 2, if that equals 0, which is what I don't want, then I get x to the second power equals negative 2. And the thing is, if I take the square root of that, that's where I'm going to get that imaginary solution. So I can say there's no real numbers that are going to make this happen. That means right here I can choose all real numbers work. And we don't have to worry about complex numbers, imaginary numbers in this situation. These are all complex, I'm sorry. These are all complex, just without the imaginary part. Okay? Basically what this is saying is any number you pick for x that's real, you're going to add 2 and it's going to be bigger than 0. Okay? The smallest this is ever going to be is 2, because 0 plus 2 equals 2. So I think for that one you should be okay. All right, I'll see you in the next video.